Hi, Professor Zioma Adonwekpete. Welcome my viewers and students to another interesting video on the Group 18 elements, also called the noble gases. They are called the noble gases because they were assumed to be non-reactive as they have filled valence shells. In 1962, Professor Neil Bartlett at the University of British Columbia proved these assumptions to be false. The elements in this group are helium, neon, argon, krypton, xenium, radium, and organicium, which is highly radioactive. Don't forget to like, subscribe, comment, and share this video. And always watch to the end of this video. The objective of this lesson. By the end of this lesson, the students should be able to identify the group 18 elements of the periodic table. Write their electronic configuration, describe their periodic trends, identify the oxidation state of some compounds of the group 18 elements. Some characteristics of this group. They have, as you can see, low boiling point that decreases down the group. Even melting point decreases down the group. Ionization energy also decreases down the group. And atomic radius increases down the group. The electronic configuration of the noble gases. We have the element and symbol, atomic number, and electronic configuration. We have helium with symbol He, atomic number 2, electronic configuration 1s2. Neon, symbol Ne, atomic number 10, electronic configuration 1s2, 2s2, 2p6. The third is argon, symbol Ar, atomic number 18, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6. Krypton with symbol Kr, atomic number 36, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d, then 4s2, and 4p6. We have xenium, symbol Xe, atomic number 54, electronic configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3t10, 4s2, 4p6, 4d10, 5s2, 5p6. And radium, symbol Rn, atomic number 86, 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, 4s2, 4p6, 4d10, 4f14, 5s2, 5p6, 5d10, 6s2, and 6p6. Unlike the halogen, the noble gases are monatomic, meaning that they do not form molecules of multiple atoms. Each molecule of the gas is just a single atom. Helium is the element that will not freeze at atmospheric pressure, no matter how low the temperature. These elements are called the noble gases, being that they have no tendency to lose or gain electrons because of a completely filled outer shell or stable configuration. Usually, under normal conditions, they do not participate in chemical reaction. All the elements of group 18 are gases. Radium and organism are radioactive ones. These gases are also called real gases because of their presence in minute quantities in the atmosphere. They are called inert because of no valence electron. However, under extreme conditions, some compounds of krypton and xenon have been synthesized. The noble gases are colorless and odorless. Looking at the argon structure we have on the slide, we just want to use argon as an example. We'll know that the first shell contains 2 electrons, The second shell contains 8 electrons, and the third shell contains 8 electrons. And the first shell is called the K shell, second shell the L shell, and the third shell the M shell. And it is regarded as 1s2 for the first shell because it is in the s orbit. That 2 electrons will enter the first orbital. The s orbital can occupy a maximum of 2 electrons. So the third electron will go into the 2s shell, and then it will occupy the 2s2 orbit and also occupy the p orbital. It has a maximum of 8 electrons. And the next electrons will go into the 3s2 orbital, and the other 6 remaining will go into the 3p orbital. So the electronic configuration for argon can be written as 1s2, 2s2, 2p6, 3s2, and 3p6. It can also be written as 288. How do they occur? We are told that the abundance in the solar system and their abundance in the Earth atmosphere, and they can be found in igneous rocks. Helium is the second most abundant element after hydrogen in the universe. It is also the second lightest element to hydrogen. It is present in all stars. It is formed from alpha decay of radioactive elements in the Earth, such as thorium and uranium. Some of the helium escapes into the atmosphere. Helium is typically produced by separating it from natural gas. Another element is neon. Neon gas is widely distributed in the universe, and it is the 5th most abundant element in the universe. Neon can be created at high temperatures by thermonuclear reactions between oxygen and carbon, which occurs in star cores. Many stars have stable isotopes of neon due to this reaction. So we say that neon, argon, krypton, and xenon are obtained from air using the methods of liquefaction of gases to convert elements to a liquid state, and fractional distillation, which separate mixtures into component parts. In the Earth atmosphere, xenon is found in traces. Some mineral springs emit xenon. Commercially, it is obtained as a byproduct of separation of air into oxygen and nitrogen. It has 8 natural occurring stable isotopes and more than 40 unstable isotopes that undergo radioactive decay. The atmosphere of planet Jupiter contains xenon as found in high quantity. Radium is isolated from the radioactive decay of radium compounds. The experiment of Neil Bartlett with xenon. It is important to explain this experiment. The widely held belief in the intrinsic lack of reactivity of the noble gases was challenged by Neil Bartlett, a British professor of chemistry at the University of British Columbia. He showed that platinum hexafluoride could oxidize oxygen. He proposed that as the ionization energy of xenon was 1170 kilojoule per mole, is actually lower than that of oxygen. So he felt that if that compound can oxidize oxygen, then he should be able to try it, that it may also react with xenon. And he also found out that platinum hexafluoride obtained a negative charge when it formed a compound with oxygen. Oxygen now became positive, which shows that compound was highly more oxidative than oxygen. And he felt like that compound is a strong oxidizing agent that will be able to react with xenon. So he tried it out. He mixed colorless xenon gas with platinum hexafluoride vapor, and he obtained a yellow-orange crystal. He was excited. He was certain that the orange-yellow solid was the world's first noble gas compound. But how will he convince others? Because every person is believing that these compounds or these elements don't react. Bartlett insisted that he had obtained the first noble gas compound. That orange-yellow solid was subsequently identified in laboratory studies as xenon hexafluoroplatinate, the world's first noble gas compound. Within months, other chemists successfully repeated the experiment. And that is the beauty of science. If you claim to have seen something, you will give them your experimental procedure. It will be repeated, and people will prove whether you got that thing or not. And they observe that that compound existed as XCF plus PTF5 minus. And that was how the first compound of xenon was obtained. And that proved that some of these noble gases can also be reactive. That was a landmark proof. The American Chemical Society and the Canadian Society for Chemistry dedicated the research of Niall Bartlett on the noble gas as an international historic chemical landmark in a ceremony on May 23, 2006 at the University of British Columbia in Vancouver. And on the plaque, it read, "In this building in 1962, Niall Bartlett demonstrated the first reaction of a noble gas. The noble gas family of elements, helium, neon, argon, krypton, xenon, and radium, had previously been regarded as inert. By combining xenon with a platinum fluoride, Bartlett created the first noble gas compound. This reaction began the field of noble gas chemistry, which became fundamental to the scientific understanding of the chemical bond. Noble gas compounds have helped create anti-tumor agents and have been used in laser treatment." What are the properties of the noble gases? Helium, neon, argon, and krypton and radium are found not to be electronegative. They are not electronegative. Electronegativity measures the amount of attraction between an atom and an electron. So these ones do not attract. What is their reaction with oxygen? Just as we said, the noble gases are chemically inert, with the exception of xenon, that can react with oxygen to form xenon trioxide, xenon tetraoxide, and also react with oxygen with sodium to form a compound Na4XCO6. And their oxide is acidic. Oxide of xenon is acidic. That's what we mean. Others don't form oxides. What of the reaction with halides? The halides are the group 17 elements that are highly electronegative. If you remember in our last class lesson, we said that fluorine is the most electronegative element, and fluorine can react with xenon, forming xenon difluoride, xenon tetrafluoride, xenon pentafluoride. And it can also react with krypton, forming krypton difluoride. And it also reacted with radium. radium difluoride. So fluorine can react with the krypton, xenium, and radium. We'll find out that their boiling point increases down the group. Below is an example of the reaction between xenium and fluorine to form these compounds. These gases, how do they form light? The noble gases are often used in fluorescent lighting and discharge lamps. This is because they easily emit electromagnetic radiation. If an electrical discharge passes through a noble gas at low pressure, the gas will glow, as seen in the image below. Each noble gas glows a different color. For example, neon is reddish orange, like in neon signs. Argon shows blue, and krypton glows a whitish purple color. It's so beautiful. Uses of the noble gases. These gases are very useful to humanity. For helium gas, it is used to blow balloons, in fire extinguisher, in airbags, cooling of reactors, testing of seals, and for MRI and LCD screen. Helium and oxygen gases are also used for a safe artificial breathing atmosphere. Argon and helium are useful for welding, used as heat shields. And a mixture of argon and neon, very good in neon lights. Helium and neon are also very useful in the automotive industry. Argon gas is very useful in the food and beverage industry to extend shelf life and maintain freshness and increase the overall quality of items. Also useful in eye surgery. Helium and argon are good for cooling systems and for lasers. Helium, neon, argon, krypton, and xenon are useful for electric light bulbs. They glow very well. Argon and krypton are useful for gas lasers. Xenium is used for insulation of double pane windows to make energy efficient. Also used as an anti gas and in photography. While krypton is good for the process of nuclear reactors and diagnosis of pulmonary embolism. These gases are very, very useful to humanity. And we have come to the end of this class. So what are the study questions? You have to give the product of the following equations. Xc plus F2, what will it give you? Xc plus 2F2, what will it produce? And Xc plus 3F2, what will we get? Who is Nell Bartlett? Give 5 uses of the noble gases. Which noble gas reacts with oxygen? Write the electronic configuration of helium, neon, and argon. I must say that I appreciate all of you for listening to the end of this lesson. Don't fail to subscribe, like, comment, and share. I thank all those that have subscribed to this video. I appreciate everyone, even those that share. Please share with your friends, share with your children. See you in the next class.